So we're going to go over some example problems of how we add and subtract rational expressions. So we're going to do a few practice problems. I have this many prepared. So we're going to do what looks like about 6 of them for your homework tonight. So we're just going to go through one at a time and see how we show our work. So the first thing we see here on these is that they don't have common denominators. So here, this denominator is made up of 3 times a, and this one's made up of just a 5. So what we can do then is we're going to get an LCD of the numbers. So 3 and 5 have a 15 in common, and then the least common denominator of the letters would just be an A. So my least common denominator in general is going to be a 15A. So on this side here, I'd want to multiply this by 5 on the top and the bottom, which gives me 35 over 15 times A. And on the other side, I just need to multiply this by 3A, because 5 times 3 would give me 15, and then it already has an A attached to it there. So after I get a common denominator, once these are the same, I keep my denominator and I add their numerators. So I'd have 35 and I'd be adding 6A. We're always going to check to see if we can simplify our answer. And since 35 and 6 don't have any common factors, we are actually going to be done there. So that's our first one. So let's go to our next one here. When we look at this again, we can see the denominator is made up of 2 parts. Each of them have numbers like 5 and 3. So the least common denominator of those numbers of 5 and 3 is going to be the number 15, right, which is 5 times 3. And then we look at the letters. The least common denominator of the x's, we would be able to multiply to make more, but we never get less. So that's going to be x to the 8th. So in general, our least common denominator is going to be 15 x to the 8th. So I want both of these denominators to say that. So like over here, to get the 15, I'm going to need to multiply by 3, and I want x to the 8th, and it already has x to the 8th. So I just need to multiply the top and the bottom by 3. So it gives me 15 x to the 8th. On the other side here, in order for this 3 to be a 15, I would need to multiply it by 5. And in order to have x to the 8th power, I would need to multiply by x squared. So if I do it on the top and the bottom, that leaves me with 20 x squared, and then again 3 times 5 is 15. X to the 6 times x squared is x to the 8th. So once their denominators are the same, I keep that denominator and I add their numerators. And then we always want to check to make sure we can simplify. So on top, I'm going to pull out the GCF of a 2. And the reason I pulled out a 2 was just to make sure that I can't reduce anything on the bottom. And since 15 can't be represented as a factor of 2, I'd be done with those. Moving on to our next one. Notice first of all that the denominators are not the same, so let's look at their number portions. This has a 7 and then this is a 1. So the least common denominator of those numbers between 7 and 1 would be the number 7. If you look at their variable aspects, n to the 3rd and n squared, the least common denominator for the variables n would just be n to the 3rd power. So in total, I want to get the common denominator of 7n to the 3rd. So in this case here, to make this 7n to the 3rd, I would just need to multiply it by 7. So if I multiply the bottom by 7, I need to do the top by 7. Now if you don't know what 7 times 27 is, just make sure you're doing your multiplication here. So like 7 times 7 is 49. Carry the 4. 7 times 2 is 14. Plus 4 is 189. Now on the other side, it already has the 7. It just needs to get n to the 3rd. So I need to multiply the top and the bottom by n. So then again, once they have common denominators, 7n cubed, I just perform the operation with their numerators. And 189 and 9, they do have a common factor, which I'm going to try to factor out. That's a 9, I believe. So 21 minus n over 7n cubed. And the only reason I did that was to see if I could reduce anything, but they don't have any common factors, so that would actually be my final answer. Moving towards the next couple examples, they look slightly different already. We can see plus or minus signs at the bottom. So when we're approaching problems like this, our least common denominator is always going to be found by simply multiplying the denominators together. So one of them is n plus 2 in the denominator. The other one is m minus 7. So we can multiply them together to get a common denominator. And as you can see here, I'm putting everything in parentheses right away. So when I multiply, I don't forget my distributive property. So if I want the least common denominator to say m plus 2 times m minus 7, I would need to multiply this side by m minus 7 on the top and the bottom. So I'm going to rewrite that fraction as 9 times n minus 7 over m minus 7 times n plus 2. I'll do the same thing on the other side. This one's missing the m plus 2, so I'd have to multiply the top and the bottom by m plus 2. So I'm just going to rewrite that as 8 times m plus 2 over m minus 7 times m plus 2. I'm trying to add these together, and we know once they have a common denominator, that common denominator is going to be the same, so we don't need to rewrite it or anything like that. We're going to keep that denominator. Now we do need to expand the top. What is 9 times n minus 7? Well, that's 9m minus 63. And then we'd have to do the same thing here. We'd have to distribute that 8, so that's 8m plus 16. So after we collect all of our like terms, again, we have a common denominator of m minus 7 times m plus 2. So I have 9m and 8m, which is a total of 17 m's. Negative 63 and positive 16 would combine to negative 47. And since the numerator doesn't have any common factors, I won't be able to factor anything out, so I know I'm done there. Looking at number 13, again, we have two very separate denominators, so our least common denominator is just going to be multiplying those together. So over on this side here, this a plus 3 needs to be multiplied by 4, whereas on the other side, this 4 would need to be multiplied by a plus 3. Now again, you can see I'm putting in parentheses around my tops and my bottoms, just so when I multiply, I don't forget anything. So I'm going to rewrite this fraction over here. So on the bottom, we have 4 times a plus 3. And on top, we have 4 times a. We're going to be adding that to this next fraction. So on the bottom, we had 4 times a plus 3. Now on top, I need to multiply these together using the FOIL method. That's why I put in my parentheses. This a plus 3 is multiplied by everything on top. So a times a is a squared. A times 3 is positive 3a. 5 times a is 5a. And at the end, 5 times 3 is positive 15. So once I have common denominators, I can keep that denominator the same, which is 4 times a plus 3 in parentheses. And I can combine the numerators. So we have an a squared, and then 3 a's, 5 a's, and 4 a's. That's a total of 12 a's. And at the end, we have a positive 15. Now, before I'm done, I'm going to try to simplify that. But we notice on top, there is no GCF, and since the leading coefficient is a 1, there is no way to get numbers that multiply to 15 and add to positive 12. So I know I'm done without simplifying any further. Looking at our last example here, again, we can see that the denominators are different, and they're represented with pluses or minuses in some cases. So that's a cue to us that we're just going to multiply them together. So I like to put everything in parentheses, so I know that the bottom should be t squared, and then on the other side multiplied by t plus 1. So I'm going to put the top and the bottom in parentheses so I can start to build my fraction. So here it already has the t squared, but it's missing the t plus 1 factor. So if I multiply the top and the bottom by t plus 1. On the other side, it already has the t plus 1, but it's missing the t squared. So I'd multiply the top and the bottom by t squared. So I'm going to rewrite the first fraction. So on the bottom, I had t plus 1 being multiplied by t squared. And I am going to distribute right away on the top, which is 5t plus 5. Then there was a plus sign in between. And then I have this new fraction, which I'm going to rewrite. So again, the denominator is common. It was t plus 1 times t squared. And then on top, I'm going to multiply right away to get 4t squared. So again, if they have the same denominators, we're able to add them together. So t plus 1 times t squared is that common denominator. So I'd be able to add the like terms on the top. So we have 4t squared plus 5t plus 5. Now, if I want to factor the top there, I'm going to see if I can factor the top. I'm actually just going to use the discriminant really fast, right? If I calculate my b squared minus 4 times a times c, which I'm using on my calculator just to speed things up a little bit, I get that discriminant is a negative number. So in other words, it's not a perfect square, so I can't factor it. So if I can't factor, then I know that that is my final answer.